Dr. M.C. Sundaraja. He completed his undergraduate studies from Madurai Kamaraj University and went on to complete his master's in structural engineering from the same. He is a doctorate from Anna University and he's also done his postdoctoral fellowship at the Queensland University of Technology, Australia. He has more than 17 years of experience in the teaching profession and he has also published papers in 39 international journals, 7 national journals, 27 international conferences and 51 national conferences. He has so far published 124 papers in various journals. He went on to receive the Best Research Paper Award from IFERP, a unit of VVERT and NIRE on 4th April 2015. He has also received Outstanding Faculty Award from the Venus International Foundation Faculty Award, VIFFA, in the year 2015. Currently, Dr. M.C. Sundaraja is now working as an assistant professor in Tyagarajar College of Engineering, Madurai.
Welcome to UGC lecture series in B-Architecture. Now we are going to have lecture 4 on design of structures 2. In the lecture 3, we have seen how to find out the moment of resistance of a singly reinforced rectangular beam. From that, we are going to find out, using that expression, we are going to design the size of section as well as the reinforcement required for it. This is the expression we have derived, that is the moment of resistance of the section. To find out the moment of resistance, we have first derive the expression for finding out the critical depth of neutral axis XC and actual depth of neutral axis of the section. Then by comparing these to x's, we are finalizing our section, that is, if x is less than xc, it is under reinforced section. Then the moment of resistance of the respective section is T into Z, that is AST into sigma ST into D minus x by 3. And if x is greater than xc, it is concluded as over reinforced section. So, C into Z is equal to Bx sigma CBC by 2 into D minus x by 3. Now, we are going to solve some problems. First one, an RC beam 300 mm wide and 700 mm deep overall is reinforced with 3 numbers of 20 mm diameter bars. The center of bars are 50 mm from the underside of the beam. The maximum stresses are not to exceed 7 Newton per millimeter squared for concrete and 190 Newton per millimeter squared for steel. Find the moment of resistance and the safely distributed load the beam can carry. The span is 6 meter. After finding out the moment of resistance of this problem, we are going to find out what is the safely distributed load by detecting its self height of the beam. That is the actual safely distributed load the beam can carry. So, here the problem is B is equal to 300 mm and overall depth is 700 mm and which is reinforced with 3 numbers of 20 mm diameter bar. 3 numbers of 20 mm diameter bar, that is AST is equal to 3 numbers of 20 mm diameter, and the center of bars are 50 mm from the underside of the beam, that is the center of bars are 50 mm from the underside of the beam. So, small d is equal to 700 minus 50, which is equal to 650 mm, is correct, and the maximum stresses are not to exceed sigma CBC equal to 7 Newton per millimeter square in concrete and 190 Newton per millimeter square for steel. Sigma ST is equal to 190 Newton per millimeter square, and find the moment of resistance of the beam. And also they are asking us to find out what is the load on the beam. So, here this is a singly reinforced. So, from the figure we can easily understand it is the singly reinforced rectangular beam. Since the beam is reinforced with the reinforcement at the tension zone only. So, it is singly reinforced beam. So, in order to find out the moment of resistance of singly reinforced beam, we are having 3 sections. One is balanced section, another is under reinforced section, third one is over reinforced section. So, based on the respective section, we are going to use the respective equation to find out the moment of resistance. So, to find out the first moment of resistance of the respective section, first to find out XC, that is the critical depth of neutral axis. Critical depth of neutral axis, that is xc divided by sigma cbc is equal to d minus xc divided by sigma st by m. This is the expression for finding out the xc. Here AST is given in the problem, that is 3 numbers of 20 mm diameter bar, 3 into pi by 4 square, that is 20 square, 942 millimeter square. Now, here xc divided by sigma cbc is 7, d is 650 minus xc divided by sigma st is given in the problem, that is 190, where m is equal to the modular ratio. This is, I have already told you that in the working stress method, that is they are using the well known mechanics, that is the modular ratio 280 by 3 sigma cbc, 280 by 3 into the sigma cbc given in the problem, that is 7 is equal to 13.33. Now, it is 13.33. So, from that we can easily find out what is xc. xc is 214.08 millimeter. This is the xc of our problem. Next, to find out x, we have already derived an expression to find out the axial depth of neutral axis, that is b x square by 2 is equal to m into ast into d minus x. I am going to substitute the parameters, that is 300 x square by 2 is equal to 13.33 into ast is 942 into where d is 650 minus x, x is the term we need to find out. So, after solving simplifying this expression, we get an quadratic equation. We need to find out the root, that is a positive root, here it is 195.115 millimeter. So, here after finding out x, we need to compare x with xc. So, here x is less than xc, it is under reinforced section. So, we need to find out the moment of resistance of the under reinforced section, mr equal to T into Ez, that is equal to AST into sigma st into d minus x by 3. We need to substitute the values 942 into the sigma st is 7 into d is 650 minus x is 195.115 millimeter, which is equal to 104.7 kilonewton meter. This is the moment of resistance. Using this moment of resistance, we are going to find out what is the safely uniformly distributed load. Before it, by equating x, this is the moment of resistance, internal moment to the external moment m, that is equal to W L square by 8. So, where mr is 104.7, which is equal to W into, where the span of beam is given in the problem, the span is 6 meter. The span is 6 square by 8, where W is equal to 23.27 kilonewton per meter. This is the uniformly distributed load we have found, which includes the self height of the beam. But they have asked us the uniformly distributed load. From this, we need to deduct the self height of the beam. Self height of the beam is normally found from the size of beam 0.3 by 0.7 by 25. 25 is the unit weight of concrete, 25 kilonewton per meter cube. That is the unit weight of concrete, which is equal to 5.25 kilonewton per meter. So, the safely distributed load, which excludes the unit the self height of the beam, is W is equal to 23.27 minus 5.25, which is equal to 18 kilonewton per meter. This is the safely distributed load for the first problem. Now, we have found the first problem, that is on the first problem they have asked us to find out the moment of resistance of the beam. Before that, we need to first find out what is xc, what is x, then you compare x with xc. We need to finalize the respective section, that is here it is x is less than xc, it is under reinforced section. the moment of resistance of the respective sections T into Z, that is A S T into sigma S T into D minus x by 3, that is 104.7 kilonewton meter. From that we are finding the safely distributed load. So, this is the moment of resistance, that is the internal moment. The external moment due to the uniformly distributed load is W L square by 8 for the simply supported beam. From that we have found W is equal to 23.27 kilonewton per meter. From this we are deducting the self weight of the beam, that is 0.3 into 0.7 into the respective unit weight, that is equal to 5.25. So, 23.27 minus 5.27 is 18 kilonewton per meter. This is the safely distributed load. Second problem, an RC beam 250 by 500 mm overall in section, 250 by 500 mm overall. This is 250 and this is 500 overall, that is D is equal to 500, B is equal to 250, is reinforced with 4 numbers of 22 mm diameter, 4 numbers of 22 diameter bar, that is 4 numbers of 22 mm diameter bar. At the bottom with a cover of 40 mm. So, the cover for the reinforcement is 40 mm and we can easily find out what is the effective depth, 500 minus 40, which is equal to 460 mm. This is the effective depth of beam. Effective depth means the depth from topmost extreme fiber to the center of reinforcement, that is the effective depth of beam. And the effective span of the beam is given, that is L is equal to LEFF is the effective span, that is 5 meter. Find the concentrated load the beam can support. In the first problem they have asked the uniformly distributed load, in the second problem they have asked the concentrated load. Concentrated load again we can find out from the moment of resistance. Take sigma CBC equal to 5, sigma ST is equal to 9. Sigma CBC equal to 5 Newton per millimeter square, sigma ST is equal to 190 Newton per millimeter square. This is the problem I have given. So, first find out whether our section is under reinforced or over reinforced. Depending upon the section, we are going to find out the moment of resistance. Using the moment of resistance, by equating the moment of resistance to the external bending moment, we are going to find out what is the concentrated load. First, to find out XC, critical depth of neutral axis, that is XC by sigma CBC is equal to D minus XC by sigma ST by m. This is the expression to find out the value of XC. So, XC divided by sigma CBC is 5, D is 460 minus XC divided by sigma ST is 190 divided by m is the modular ratio 280 by 3 sigma CBC, which is equal to 18.67. 18.67, that is. So, from that XC is equal to 156.44 millimeter. Then we need to find out X. X is found from the formula B x square by 2 equal to m into AST into D minus x. By substituting the parameters, that is 250 into x square by 2, which is equal to 18.67 into AST 18.66, do not round off the values, 18.66 into AST, here it is 4 numbers of 22 mm diameter bar, 22 square, which is equal to 1520 millimeter square. So, 1520 into D is 460 minus x. So, from that we have found x as 230 mm. So, by comparing x with xc, here x is greater than xc, it is over reinforced section. In the first problem we have seen under reinforced section, but here this problem falls under over reinforced section. So, the moment of resistance of the over reinforced section is C into Z, that is B x sigma C B C by 2 into D minus x by 3. B is 250, x is 230, sigma C B C is 5 by 2, D is 460 minus 230 by 2, that is equal to the moment of resistance here it is 58.05 kilonewton per kilonewton meter. This is the moment. Now, self weight of the beam. I am going to find out what is the concentrated load, but self weight of the beam is a uniformly distributed load, that I am going to deduct this self weight of the beam from the moment of resistance, that is the external load, that is uniformly distributed, that is 0.25 into 0.5 into 25 is equal to 3.125 kilonewton per meter. So, by equating moment of resistance to the bending moment, external bending moment, that is equal to W L square by 8, that is 58.05, which is equal to W into L is 5 meter, 5 square by 8, which is equal to the self weight of the beam moment due to self weight, that is W is 3.125 into 5 square by 8, that is 9.765 kilonewton per meter, kilonewton meter. This is the moment. So, net moment, I am deducting the moment of self weight from the total moment, that is 58.05 minus 9.765 is equal to 48.285. This is the net moment after deducting the self weight of the beam. Now, using this moment, now I am going to find out what is the concentrated load on the beam. I am assuming that the concentrated load is acting at the center of the beam. The moment is W L by 4, is correct. So, 5 into W by 4, which is equal to 48.225, where capital W is equal to 38.628 kilonewton. This is the concentrated load acting on the beam. In the last problem, we have found the uniformly distributed load, that is 18 kilonewton per meter after detecting self weight. So, in this problem they have asked us to find out the concentrated load. So, once we find out the moment of resistance, we have found the self weight. Due to the self weight, we have found the moment, then that moment has to be deducted from the total moment, that is 48.225. From this moment, I have found the concentrated load acting on the beam. This is the way to analyze the section. Next one, to design the section, how to design the singly reinforced rectangular section. First problem, the cross section of rectangular beam has to resist a bending moment of 75 kilonewton meter. If the beam is 250 millimeter wide and the permissible stresses in concrete and steel are 5 Newton per millimeter square and 190 Newton per millimeter square respectively, find the effective depth and the tensile reinforcement. They ask us to find out what is the effective depth of beam as well as the reinforcement required for it. Now, let us start designing. So, here, and this is the rectangular beam they have asked us to design. So, here the cross section of the beam has to resist the bending moment of M is equal to 75 kilonewton meter, and the beam breadth of beam is B is equal to 250 mm, and the permissible stresses in the concrete sigma CBC equal to 5 Newton per millimeter square, and sigma ST is equal to 190 Newton per millimeter square. They ask us to find out what is the effective depth of beam, what is the moment ASF. So, we have two expressions, that is moment of resistance equal to T into Z that is AST into sigma ST into d minus x by 3. This is a one equation. Then another equation we have, that is C into Z, that is B x sigma CBC by 2 into d minus x by 3. The first expression which is used to find out area of steel, the second expression which is used to find out the effective depth of beam by assuming the B, but B is given in the problem 250. So, first we need to assume given section is the balanced section. Assume section is balanced to 1. But to find out XC, XC divided by sigma CBC is equal to d minus XC divided by sigma ST by m. So, m is given in m is equal to 280 by 3 sigma CBC, that is equal to 18.66. So, XC divided by sigma CBC is 5, d minus XC, XC here it is, we need to find out sigma ST is 190 divided by 18.66. So, we have found XC is in terms of d. XC in terms of d here it is 0.89. I am going to substitute this XC in the moment of resistance, that is MR is equal to BXC sigma CBC by 2 into d minus XC by 3. So, moment is given in the problem, that is m, by equating m equal to MR, 75 into 10 to the power 6 is equal to 250 into XC, here it is 0.89 into d into sigma CBC is 5 by 2 into d is, we are going to find out XC is again 0.89 into d divided by 3. From that I can find what is d, here it is 639.22 millimeter. This is the depth of beam, it can be equated to 640 mm. Now, to find out AST. So, m is equal to MR is equal to AST into sigma ST into d minus XC by 3. By equating that moment of a second expression, I am finding that is 75 into 10 to the power 6, that is Newton millimeter. Kilonewton meter is equal to 75 into 10 to the power 6. 10 to the power 6 means 10 to the power 3 Newton, 10 to the power 3 again 10 to the power 3 meter is converted into millimeter. That is AST into sigma ST, here it is 190 into d is 640, we have found, minus XC is 0.89 into 640 divided by 3. So, AST is equal to 693 millimeter square. Let us summarize so far in this lecture. In this lecture we have seen the analysis of singly reinforced rectangular beam and the design of singly reinforced rectangular beam by doing some problems. So, from that I hope that we can understand how to find out the moment of resistance and the design of reinforced rectangular section. And the questions. So, here I have given you one question to design this singly reinforced rectangular section, that is cross section of RC beam is required to resist the bending moment of 65 kilonewton. Find the dimension of the section and also the steel required. Assume that sigma CBC equal to 7 Newton per millimeter square and sigma ST is equal to 190 Newton per millimeter square. And in the case of references, we can refer the IS code 456-2000 plain and reinforced concrete code of practice, and one book which is written by S10 Sinha, the title is Reinforced Concrete Design. With this we come to the end of this lecture. Thank you.